Hi everyone, welcome to talk session. Let's continue with few more examples on designing of DFA. Here question is, design DFA to accept all strings where length of the string should be divisible by 5. So first try to identify the condition and understand it. Which are the numbers divisible by 5? When I say divisible by 5 means what? If any number gets divided by 5, remainder should be 0. So if 5 divides 5, remainder is 0. 10 divides 5, remainder is 0. Similar for 15. Also, if 0 gets divided by 5, we are getting remainder 0. So we are going to accept 0 length string also. Hence, based on these numbers, write down the minimum length string first. What is the string having length 0? That is epsilon. What are the strings whose length is 5? Our sigma is a comma b. Here we need to concentrate on the length of the string and not on the format. First symbol may be a or b, any combination of a and b. The only thing is that length of the string should be divisible by 5. If I write here 5a's, that is also fine. If I write here 5b's, that will also work because length of the string should be 5, or any combination of a and b is accepted because length should be 5. Once we understand the condition, we need not to write further strings. Try to design automata for this minimum number of strings. Automata consists of various states and states are represented by circle. First state is Q0. As we know, when your epsilon is a part of minimum length string, our starting state becomes final state. So epsilon gets accepted. Take the next valid string AAA. Sorry, it's a 5a's. As length is 5, it's divisible by 5. So this 5 length string should get accepted. It means what? By reading this string, automata should reach out to final state. As we know, one state read one symbol at a time. So Q0 is reading the first A. Single A should not get accepted. So automata is going to the state Q1. Second symbol is A. Q1 is reading second symbol. Two length string should not get accepted. So automata is going to the non-final state. Third symbol is A. Q2 reading the third symbol. 1, 2, 3. Three length string should not get accepted. So automata is going to the state non-final. Fourth symbol is A. Q3 reading the fourth symbol. Similarly, 4 length string should not get accepted. So this transition is going to the non-final state. Next symbol is A. That is the fifth symbol, as first A, second A, third, fourth, and Q4 reading the fifth A. As we know, length of the string should be divisible by 5. Hence, transition of this fifth A should reach out to final state. But already we have existing final state. So we can connect transition of this Q4 to Q0 for fifth A. There might be a question in your mind why we are not creating the new final state. Because we are utilizing the existing final state. Hence, we are connecting transition from Q4 for the fifth A to Q0. Unless and until this transition is not reading any invalid string. Hence, I am removing the transition. For the new final state, it's not required. Also, our DFA should always contain minimum number of states. Now, transition of this fifth A is going to the final state. Hence, this string is accepted. Similarly, I can check for the 5b's. Design automata for 5b's because length of the string is 5, divisible by 5. So, first symbol is B. Starting state is Q0. As I mentioned here, we need to focus on length of the string and not the specific symbol. So first symbol may be A or it may be B. So Q0 reading the B. Second symbol is B. Again Q1 can read A or B. Q2 can read A or B. Q3 can read A or B. Q4 can also read A or B. How to read this? Q0 can read A or Q0 can read B going to state Q1. Q1 can read A or B going to state Q2. Similarly, we can further read for the next state. Now, check is any string is getting accepted by this automata or not. If I take this string here, A, triple B, A. First symbol is A. Second symbol, third, fourth is B. And the last symbol is A. So, write down this string and start checking whether this string is getting accepted or not. First symbol, first state, Q0 reading the A. Once Q0 reads A, going to state Q1. What is the second symbol? B. B getting read by the Q1. Q1 reading B, going to state Q2. third symbol B. Q2 reading the third symbol, going to state Q3. Q3 reading the fourth symbol, again it's a B, going to state Q4. Q4 reading the last and fifth symbol A. So Q4 reading the last and fifth symbol A, going to state Q0. Automata is in the state Q0. String is also completed. As string is completed, automata is in the state Q0, and I know as Q0 is a final state. Hence, this string is valid and it's getting accepted by this automata. Also, this automata is deterministic. What is deterministic? Deterministic means what? For each symbol of sigma, there must be only one transition from each state. Here, if you observe, there is a transition for A and B from Q0. Similarly, from Q1, and from all the states, there is a transition for A and B. Hence, all states are deterministic. Hence, this automata is deterministic. And this is final answer for this question. You can practice similar question to accept all the strings where length is divisible by 5. The only difference is that here sigma is 0, 1, and in our example sigma was A, B. In the next session we will learn few more examples where we need to design DFA that's going to accept all the string where number of A's are divisible by 2, 3, 5. Here especially we are focusing on number of A's. In our previous example we were focusing on the length of the string. Thank you for watching.